Well, I think Barklod, we've talked past each other a little bit in this, but not in a bad way. I don't think it's past each other. I think we skew angles, but, you know, not so much past each other, but it's coming on by here, and I'm like, hey, no, but this isn't what I meant. And you're like, hey, but this is similar, this is related, but not what I meant. That's what I think's going on. And I thought I maybe made myself clear, hopefully. I hadn't had feedback from you, but... you know, the sense in which I don't mean everybody has to become like it's a religion, like somebody has to become a scientist and look at the universe that way. But I am saying that that science will always have something relevant to say eventually. You know, so we seem to agree on that science can turn its eye anywhere, and that's sort of what is the important part to me, because there is no ever getting all this knowledge. I think there's infinite knowledge. And you bring up the infinite regress of causality. Yeah, well, like as with the coordinate systems and the power series and the Fourier transforms and whatnot, you know, I think that there's a good metaphor in math about this, which is that mathematics, you know, whenever it was, I'm forgetting now, 1500s, or was it 16 or 18, I don't know. Mathematics figured out how to do infinite sums. And this is really important. Cantor's work on the fact that there are different sizes to infinity. There's more than one kind of infinity. Basically, the infinity of all of the points in a plane is different from the infinity of all the points in a three-dimensional space. So, like, I guess better to say that there's an infinite number of points in a line segment, right? A one-dimensional line segment. There's an infinite number of points in a two-dimensional plane. It's actually a bigger infinite number, because you can't map from one to the... Anyway, read Cantor if you want to see what he's saying. You don't have to accept every single one of these things, though there's, you know, there's so much mathematical backing. It defies the word accept. It's just you have to understand the pattern they're showing you. You can say, well, the universe doesn't follow that pattern, but the pattern itself is you know, coherently made. So why they're saying there's different sizes of infinity becomes clear. And similarly, when I was first learning about asymptotes, to me, I just saw a deep meaning in life. That you could have a curve that reaches a point at infinity, right? You can have a curve that never reaches a particular point. It gets closer and closer to that point, and the difference between those two kinds of limits, fundamentally interesting. And the fact that you can predict which is which, like with a geometric sum, you know, with a logarithm, it never reaches the asymptote. But with a geometric sum, like the Zeno's paradox of crossing a road, what if I split the road in half and in half and in half and in half and in half? What are they? See, that was Zeno's basic paradox, is a misunderstanding of infinite sums, right? Common sense. The idea that if I broke a road up into an infinite number of half segments, each getting half smaller, and add them up, since there's an infinite number, it's going to be infinitely wide. But there's another common sense thing that could be figured out, which is if I split it up in half, I start with something, I split it in half, and I add it back together, it'll be the whole thing. And how do we do that? Well, with induction, and that's why, you know, mathematics, according to the real analysis class I took, which is one of the weirdest classes in which you prove A equals A and stuff. To have a mathematics, there were 3 rules, I think, and one is that A has to equal A. So if you make a bunch of rules, you have to prove A continues to equal A, or does in the first place. And induction has to be true, and then some other thing, I forget, maybe you have to be able to say something's greater than something else, or something like this. But induction has to be true. And if induction is true, then you can figure out things. Induction being also, the definition of induction in mathematics helps one understand what induction really means. In mathematics, it's basically, induction is that if n is the case, and I can prove n plus 1 is the case, then I can prove, you know, n plus anything, right? Because n plus 1, then n plus 1 becomes n, and so n plus 1. So that's how you basically can prove n, and that n plus 1 follows from n, and boom, you can prove a whole infinite series, and not just prove something like I have a truth and you have to believe it, but like you can do the infinite series and do the math and find out what, you know, a third plus a sixth plus a 12th plus a whatever, you know, you can figure out the actual values. And that kind of math allows calculus to exist, and there we have real physical confirmation. I mean, mathematicians did this for fun and then figure out how these things all turn out to be useful, and figure out later you have, you know, if you have a, what is it, oh, now I'm going to get it backwards. If you have a curve showing something's velocity, the volume is like how much, over time, the volume will be how much distance it covered, I think, right? And the slope of the curve is the acceleration. If you have a curve of the acceleration, the volume is the velocity, and I might be screwing that up. I guess I should go refresh my calculus. But there's these relationships with physical things from being able to do the infinite series, and it's a way to check that you're not just crazy with the infinite series, right? Because you have something where you can mathematically predict what it is, and you also have an experiment where you could just have directly measured the velocity and all these things, and you could double check your math. Of course, we're so sure in the math by now we don't even think of it that way, but it has all been double checked, triple checked, quadruple checked in some systems. Okay, and I don't mean checked over and over the same check, I mean checked from a different angle, like the way they derived the speed of light. Like the electromagnetic waves, there were several different ways that calculated these speeds, and they were all the speed of light. It's like, that's interesting. Okay. You compare the infinite regressive causality to the single regressive existence. Well, I think the existence is an error. It's a simplification just for that reason, to feel like you don't have to deal with, you know, it's like a gross approximation of a world that really does have infinite cycles in it. And I believe the universe is infinite, and this is the fundamental issue. So maybe this is something I could emphasize more with my points, is that I want a system that handles the fact that we are immersed in an infinite medium. And it's like the word random versus probability. Infinite doesn't mean anything. Like if you have infinite points on a line, it doesn't include a point over here. It's just on this line segment. It doesn't, you know, it's like it's infinite. It doesn't mean anything. Still very regular. The way which points out of the universe are on a particular line, still very particular. There's infinite. We're in an infinite media like that. So there's regularity. You can say I'm on a line, but there's infinite always variations around whatever you're doing. Even if it's back and forth on a line around you, there's always this discrete foamy you know, kind of noise at some level that keeps things from being particular. And so I don't even like to think of points on a line, of course. I like to think of the little infinitesimals. That's what's on the line and oriented to the line and part of the line. Yeah, and the technology versus science, I'm saying they have separate lineage. I don't really want to say which came first, because that just implies the consequentialism, and I think the root of science goes back a long time, way before we would have called it science, and is a part of the human cognitive condition, just like doing philosophy is. And I do believe science goes back to natural philosophy, so I like to say any philosopher way back that was thinking, you know, naturally as opposed to metaphysically, you know, thinking that the world's made up of the stuff right here, the tangible, feelable, seeable stuff, as opposed to it was an illusion from another world. I consider that, you know, part of the ancestry of science, whether you want to call it science or not. So let's not say which one came first so much, but the same issue of they're separate. Look, fire and the wheel are technology. They're so old we don't even know where they come from. Science, especially what we want to conventionally call science, not my version of natural philosophy back forever, but actual science, a few hundred years. So I think it's clear. Now, science gives us knowledge, but you can't suddenly blame science for the technology. The club, it's made it better. But science has made our health care methods more effective. You know, there's negative parts of it, but there's practical, you know, lifespan's getting longer part. And, you know, technology also requires finance industry. Why don't you go to the finance industry for the source of the evil? Okay, because I see things about the way the finance industry works that might be why you see so much negatives out of technology. And I mean you in particular, things you perceive as negative. You know, why would it be science? Well, I'll tell you why. It's because the financial guys are like, blame the eggheads. Egghead, give me more information. I'm going to build a laser ray of death. Do you see those scientists keep building laser rays of death in their labs? Of course, I'm the one that builds 40 million of them and sends them all over the world. Yeah, the senses as a technology, yeah, definitely. So it's more that science runs off of technology. At first you could do sciences with your eyes and stuff, and then you start to make little devices basically to make your eyes better and better, including magnifying glasses so you can read a little tiny reading or something, you know, on a ruler. So technology is like an extension of the senses. Science relies on that. You get more information, which means that you get more ideas for extending your senses and your motor functions. So, yeah, so that's why I don't see science as negative, because I don't have it munged up with technology in the finance industry. A lot of what you're saying reminds me of YouTube atheism. YouTube atheism to me is an example of negative scientism. Like people that understand science less, say, even than, well, that's too insulting. Like Gary's a funny case because he understands classical physics pretty well, and he's become and already was, you know, familiar with this to a certain degree with what people were saying in modern physics, but you know, I don't think he gets modern physics at all. There are YouTube atheists that don't understand science even as well as Gary, like don't understand the classical parts, and yet they are scientismists or something. Like they are what you were. Like a lot of the people defending Thunderfoot and Thunderfoot himself, and that it's like, well, you're using a cell phone, that's why you have to believe in science. You know, they make this connection that the pragmatism of science is, look, we got GPS, which is no. The pragmatism of science is you get to realize something like the Earth is round. This is spiritual level surrealness. Now we've made it mundane. And that's because we digested it. But when it first comes, and see, I remember being a kid. I remember digesting the fact that the world was round. This is the kind of thing that made me fall in love with science, because, you know, at 5 and 6, I remember, like I was 3, my dad telling me we're walking. No, it must have been like 2, because my mom and dad were still together. And we're walking in San Francisco. And I remember my dad going, my dad's saying, the Earth is round and it spins. I don't see how I could be that young and remember this. But we only lived in San Francisco till I was about 2. And then split up. But maybe they were hanging out together the next year, because maybe 3, 4. But anyway, that the word was round and it spun, but then he said it's spinning this way because I'm walking in this direction. You know, like an ego joke. Found out it wasn't really a joke, but anyway, forget that. Okay, so I remember finding out things like that the Earth was round, and that was fascinating to me at the time. And I'm like, we should be able to hold on to that, because look, that means when you're coming from the world is all spread out like it looks like, that means if I go in this direction long enough, I'm going to come up behind myself. That's bizarre. And you make it mundane as you understand it, as you leave the world is is this spread out thing to the world as a curved thing. As you transition those beliefs, it becomes like, well, of course it is, and I'm stuck to it because of gravity, and it becomes seemingly mundane. Right? And that's spiritual growth to me. Learning things like that. Okay. That's the practical thing, is that there's an enlightenment there, and the lights that shine out into whatever this world that is the source of these perceptions, whatever kind of world it really turns out to be, I'm seeing more. There's more light. And as that happens, I see more connections and systems between me and other things. You know? And that just seems crucial to me. And I don't know what else does that consistently for millions of people over the culture. Yeah, you can discover a poet or a musician. You know, when I first found out about Jack Johnson, I listened to nothing but Jack Johnson for like 6 months. That also was a growth experience. But when that fades out, fine, it's like a nugget or a fruit that you can find. Whereas science is a field that can continually, sow the fields with these kinds of things that create, other sorts of experiences that you wouldn't want to call scientific, that are important to the human experience overall. But I just don't go for any old kind of criticism of science, and I especially don't like the science is technology, science thing. And I don't want a love of natural philosophy, which is the kind of science I'm talking about, to be related to, pseudoscientific dogmatism. I mean, my view of science, you have theories, there is no dogmatism allowed. Any dogmatism is deviation from science. The theories are open, we know they're going to become better informed. We know nothing is fully informed. They study how sure are we about something. There's always some amount of statistical sigma. It's just that after 5 or 6, 7 sigma, it's almost ridiculous to worry about the odds that are left. They get so tiny. But then you have the whole paradigm change issue, that when you get your sigma up to whatever, you will find a new orthogonal direction that your model has to go. You'll add dimensionality, and your model will still be right to that sigma, but it'll just have been a cross section. And you'll find out there's some sort of parameter you can tweak that brings things here and changes. And then you'll find the continuity in this dimension. And every time you're proved wrong, you become better informed. How's that a bad thing? Why is that not something that we should do in our everyday life? This kind of process is a part of enjoying a sunny day to me. Because I want to have a theory. Like, if I think sunny days are really great, and then I go out and have a bad time on a sunny day, I get more informed and I realize, well, they're great if you're in the mood, or they're great if... And then I realize, well, no, sunny days aren't the great thing. The sun is great, but sometimes it doesn't make my day great. The heat of the sun is a great thing. And I refine and inform myself. I didn't get wrong about sunny days. Most sunny days are especially good to go out in. I increased my understanding. I didn't lose why days with the sun out are good. It's because it's a good influence. But just as an example, right? To me, I just don't see why the science, like everything in my life, is a theory that can be better informed. Whether someone loves me, or whether somebody this is or that's or another thing, or whether my car is in good shape, or my house is clean enough, or anything, can always be better informed. Now, I don't have time. I have priorities. My time is valuable. Not all information is worth my time to get it, but it's always there. If I had robot helpers, I'd probably say, yeah, go get that information that I can't be bothered to get. and then process it, and if it's level 2 information after your programming, which I wrote, is run, then tell me, And it just says time management. So the information's always out there, and statistics help you figure out where you ought to look next, where the right chances are. And this pragmatism is getting gadgets kind of thing is annoying to me. I'm just reading slowly, but Utilitarianism by Mill, which I think I read, but I don't remember it. But I'm pretty sure. No, I'm pretty sure I did. And he starts off the argument exactly that people that think pragmatism is just like, mundane, getting the technology. No, pragmatism is satisfaction or happiness, something to do with how a person feels about it. The practical thing is to try to feel good. And I think a lot of people living in Gadgetville don't even know. They just confuse themselves so they can't figure out if it's good or not. They're like, I don't want to think through. I'm just enjoying the sunny day. It must be great. This is the top, right? They don't dig in. And I think they should. I think more people should be not scientists like a profession, but scientific in the sense of taking a natural philosophy approach to themselves as parts of nature. On the beginning, you have to be careful because time is a weird thing that we don't exactly understand. But there doesn't necessarily have to be something before something else for there to be a beginning. And I think this is the way the science is going. But for example, not that this is a theory really of anybody's, but you can get. I think there's a sort of surreal common sense to this. Hopefully, what if everything falls into black holes over time because they just tend to grow? They do radiate. Supposedly, if they're small enough, they'd evaporate. But a big black hole, which we've seen that we've got these big black holes, just keeps sucking I almost said information, but mass into it. Well, with the weird quantum physics, there is physics to imply that things could travel back in time, but when everything is the wormhole and potentially inside a black hole is a candidate for that. But the funny thing is the tidal forces are so strong in a black hole, infinite, that they tear up everything right down to energy. So everything would be sent back in time and emerge as energy. So what if we're 14 billion years from the beginning and we always will be? Because it's a 100 billion year loop, and the stuff eventually falls in and the universe becomes cold, and that energy goes back to the beginning of time, and there's nothing before the beginning, but it's still the beginning because that's the point in time where the energy comes out. These kinds of things, I'm not saying I believe that, but these kinds of things are the candidates now. So we just can't use 2,000-year-old before and then and if. See, you're kind of using the causal logic to say that. And I'm saying that science is so flexible that they've actually we were told the idea of cause and effect was a metaphysic for thousands of years. And scientists were like basically buying that and doing a lot with it. But because of the way the theories are open and get informed, they've come up with a new model of causation because they had to. And that's the thing. They got informed in a way that no classical notion of causation would work. They just made a new one without even understanding what they were modeling. Just like, okay, well, let's look at what's happening and try to, and they got a hold of something that explained this, and it's like, it explains it really well. Now, the problem is we don't understand our own explanation philosophically, and that's because we're still stuck classical thinking. All we have to do to understand it is change. One big change is change every definition to a relativistic. There's such a thing as relatively certain. There's such a thing as knowledge that's an error. We allow all the relativistic definitions. That goes a long way. But then other things are more technical, not so easy. Like a new idea of causation and learning about fields and maybe thinking of everything in terms of sets or containership and abstractions from math, these tools of infinity. We need to find out what is missing in our understanding of these things, like understanding infinite sums, and then learn about infinite sums. And the more you do that, the more it starts to be clear how the way the world is makes more sense than the way we thought it ought to make sense for it to be. So, but yeah, I don't think you're bad-mouthing science in that way, but it did come out that way. You were, in fact, in a few comments making, but I don't think you fully feel that way. But there's room for a conversation here with these subjects can be illuminated, just because you do have some of this tendency to guilt by association science. I think we have the means of historical and logical tools here to like sort that out, and to an arrangement that I would think makes it obvious that this process of learning of natural philosophy and science as natural philosophy, I'll real Scotsman it if you want. That's real science. It doesn't matter if somebody's even educated in science when they're being scientifically dogmatic and going, well, we have 3 metaphysical assumptions and we believe them because we got cell phones. And as much as I love scientists, I found they don't know much about the history of science, and actually also about philosophical logic. They understand the scientific logical ideas, but like basic epistemology, do we have to assume it exists or whatever, they mostly are like, well, I don't have to even worry about it because I'm just taking data and making models for it. I leave it to somebody else to explain off it.